Okay, so today's lesson is I can solve a system by graphing each line. Okay, so remember, when we're trying to solve systems, we're looking to see where those two lines cross because that's where they have the same solution. Let me zoom out just a bit here so my graph can fit. All right, so I want to take both of these lines and graph them as the best I can to see where they cross in order to determine a solution. So for each line, I have to get them in slope-intercept form. Okay, so y equals mx plus b. Alright, so I'm going to take the equations one at a time. So we got x minus y equals 1 and solve them for y. So this first one, to get y by itself, I need to subtract the x from both sides. So negative y is equal to, remember I can't combine x and 1 because they're not like terms. So I get negative x plus 1 and then divide everything by negative 1 to get the y by itself. So I'm left with y equals positive x minus 1. Alright, my second line, which I'm going to do in purple, to solve for y. So I get 5x minus 4y equals 0. So I subtract the 5x, gets negative 4y is equal to negative 5x. And then I have to divide both sides by negative 4. Okay, negative over negative is a positive, so I get 5 over 4x. Okay, but there's no y-intercept, right? So that doesn't have to worry about. I don't have to worry about that. Okay, so to graph each line independently, so my slope of the first line, this 1 in front of the x, so my slope is 1 over 1. Or, remember for our purposes, we could also do negative 1 over negative 1. So flip them both, right? And my b, y-intercept, is negative 1. Okay, when in doubt, always start alphabetical order. So I'm going to start b with my negative 1. That's my y-intercept. So go to the origin, go down 1, and then use my slope, up 1 over 1, as many times as you can. Okay? So you want to fill the graph to as high as you can go, and also go down 1 to the left 1, as much as you can in a line. Okay, so I've got that first line in, and I'm just going to leave it as the series of dots because I'm really only concerned where they cross. So as I'm graphing the second line, I just need to be aware of to see where it will cross. Okay, so for my second line, I'm going to add in that plus 0 just to remind myself that my y-intercept is in fact 0. Okay, and my slope is 5 over 4, okay, or negative 5 over negative 4. Okay, so remember, our last step is to graph both lines and find the solution. Okay, so I've got my y-intercept is 0, and then I want to go up 5 over 4, up 5 over 4. Alright, so that's where I ended up there. And I'm going to go down 5 over 4. Oh, look, there's already a dot there for red, so that means that this must be where the two lines cross. So if I draw them in very carefully, that will be the point where they intersect. So that must be my solution. All right. So they cross at what appears to be negative 4, negative 5. Okay, so my solution is negative 4, negative 5. Okay, So for the second problem, I would like you to try it on your own. So pause the video real quick. Try to graph and solve this system of equations. Okay, so what you should have done, you should have noticed that the second equation here is already in y equals mx plus b form. So that's fine. We don't have to worry about that one. However, this first equation, 15x minus 3y equals 9, is not. So to get that in slope-intercept form. Okay, so we should have done, subtract 15x, get negative 3y is equal to negative 15x plus 9. Okay, and then divide everything by negative 3. Okay, so you get y is equal to 5x minus 3. Ooh, well, that's a problem. We should have noticed that both of these things are exactly the same, right? Y equals 5x minus 3, y equals 5x minus 3. So I'll go ahead and graph the first one. I got my slope is 5 over 1. My y-intercept b is negative 3. Okay, so I'll plot that. And what you should have done is up 5 over 1. Up 5 over 1. That goes to about right there, and then down 5 to the left 1. About right there. Now if I graph the second line, what you're going to notice is that they touch at every point, right? My slope is the same, and my start point is the same. So I'm going to start at negative 3, which is the same point, and then go up 5 over 1, same point, up 5 over 1, same point, same point. So if I draw in both of these lines, they're both going to be completely overlapping. In terms of the number of solutions, if the lines completely overlap, that means that they're crossing at every point. So what should that mean for how many solutions that I have? Well, it doesn't matter what point I make, so this is one of those situations where when they're the same line, they're overlapping, it's infinitely many solutions. Okay, so think about that one for tonight. Come back tomorrow ready to discuss and practice. All right, have a good night.